Hi everyone, welcome back. In this lecture, we will stop at where actually we have stopped in the last lecture. You see, in the last lecture where we have stopped it is we were looking at the zeros of the polynomial geometrically. Now, as far as I have already told you that you take any polynomial, you can plot it in the Cartesian plane wherever it cuts the x-axis, and that number is the zero of the polynomial. So, for example, here the 3 is the zero of the polynomial and 2 is the zero of the polynomial because the polynomial cuts exactly at 2 and 3 the x-axis. Now I have a couple of more, in fact many other examples to confirm these things, and also we want to visualize these things. Now let's look at the first polynomial over here, which is not cutting the x-axis at all. And what does that mean? That means there is no zero of the polynomial. In fact, that I can write as simply no zero. No zeros. There is no zeros for this polynomial. Now, what about this? Of course, you might have noticed there is a zero at this place, there is a zero at this place. That means these two are actually zeros of the polynomials. So, zeros, which means 0 and 1 are the zeros of the polynomial. Okay, now here again we have seen this one and this one. So there are two people here, 1 and then here is the 4. So 1 and 4 are the zeros of the polynomial. Okay, fine. Now what about this graph? Now this graph has intersecting the x-axis at this place, as well as at this place. If you want me to zoom in a bit, you see that here at 1, at 2, as well as at 3, the graph is actually intersecting. Now, these are the zeros of the polynomial. That means 1, 2, and 3 are the zeros of the polynomial. Here, whatever the polynomial is refers to. Okay, fine. Now, what about the next? I have a next polynomial in line. See here, this polynomial is intersecting at 0 and 1 and 3. That means 0, 1 and 3 are the zeros. Zeros of the polynomial. Okay, fine. Now what about the other two? You can see that here, now how many zeros are there? Now here you can actually clearly notice it is touching the 0, right? You can see that it does not cut through the 0. All that it does is actually it touches the 0. And that means I'm going to say that there are still 3 zeros for these polynomials, where 2 of them are simply just 0. That means when I want to count the number of zeros for this polynomial, I would simply say 0 and another 0 and then 3. And for what reason? If you see the 3 over here, it just cuts through the 3 and hence it will be counted only once. But at this place, what it does is, it is not cutting through the 3, whereas cutting through the 0, all that it does is, it is actually reaching the 0 at this place. And imagine the graph is going somewhere else and then again coming back through 0. So that time what we will do is, we will think of that as the graph is actually cutting 0 at 2 different times, and hence 0 is this 0 is the 0 twice. In other words, 2 times actually that has been considered as zeros. So there are 3 zeros where 2 zeros are actually literally the 0 itself. Okay, fine. So here are the zeros of the polynomials. Zeros of the polynomials. Now what about the last example I have here? And this example says what? You can see that very clearly. In the x-axis, there is only one place that it get cut, and the other places it does not even touch the x-axis. That means here there is only 1 0 of the polynomial. Hopefully that makes sense. And that actually brings a lot of questions to us. That first of all, how do we even decide that how many number of zeros of the polynomials will be possible? And how do we even define that actually what are the zeros of the polynomial, etc., right? Now for that I have a simple answer to tell you. In fact, if you see that the graphs very clearly, wherever it cuts x-axis, that is the only number of zero polynomial. So for the first one, zero number of zero number of zeros. For the second one there are two. For the third one there are two again. For the third one there are three zeros, and for the fourth one again three zeros. For the fifth one there are again three zeros, remember, because I just explained if the graph touches the particular x-axis, that means you should consider that from the left it cuts once and from the right it cuts again. So that makes this is again three zeros, and here there is only one time it cuts the x-axis, neither of the time it is actually touches or cuts the x-axis, and that means this makes only one time the zero of the polynomial. One time that cuts x-axis, that means there is only one zero of the polynomial is here. Okay, fine. Now literally speaking, in your 11th and 12th standard when you are coming up, you're going to learn something called complex numbers, and that's going to actually fill the gap of the remaining zero of the polynomial, whatever I'm talking about. I am not actually here to scare you. I'm not actually telling you that you have to learn complex number right away. All that you can think of right now here is the zero of the polynomial means, is there any real number which will make the polynomial is 0? That's all we do. In other words, is there any number that we know so far which will make the polynomial is 0 or not? So how many of them? It's up to us. Now I can give you one guarantee that what will happen if you have a linear polynomial or quadratic polynomial. So let's write that one by one. So the question was number of zeros of the polynomial. So as I said, in your future classes you're gonna learn there are other zeros of the polynomials as well which does not cut x-axis. That means there are numbers which is going to not cut the x-axis, but still actually it will become a zero of the polynomial, but not now, it is going to be in future. So to do that, what I'm going to do is, for a safer side, for a linear polynomial, since the degree is only 1, it can have exactly 1 0. And for a quadratic polynomial, since the degree is 2, it can have at the most 2 zeros. Remember, I am safely using the word at the most here. You need to be careful. That means it need not have any zero at all. You can see that one example that we have seen in the first one. You see that this is the parabola over here. You can even easily figure out that that must become a quadratic polynomial, and I can even show you in the GeoGebra over here. You see that here, let me type that polynomial here, x square and then plus 2x plus, let's say, 6 or maybe 4. Okay, now you see that here, now this is a quadratic polynomial, whatever I have typed, and you see that the diagram is a parabolic graph over here. It does not cut the x-axis at all, right? That means there are quadratic polynomials, or in other words, there are polynomials of degree 2 in which there is no zero exists. That means we also have to say very carefully that for a quadratic polynomial, at the most I can get 2 zeros, meaning it can cut the x-axis maximum by 2 times. That's the idea. Okay, fine. Now for a cubic polynomial, what will happen? Again, same thing. Now I can safely replace this word by at most 3 zeros because of the degree. You can notice here as well. In the previous example I was shown, you can first of all look at how a 3 cubic polynomial would look like. Let me take this off and then draw another graph. I'm sorry. Oh, that got stuck. I'm sorry. Let me let me fix that here itself. I think The GeoGebra for me got stuck. Let me see that a little bit later. But you can think of this. See, any cubic polynomial will be of this kind of format if it has three different zeros. If it has two zeros are same and if it has only one zero differently, then it will have this format, as I have noticed here. Now suppose if it has only one zero, then the cubic polynomial will be of this form. So wherever it cuts the x-axis, only one place it will cut, and two other places it's supposed to cut will not cut at all. Okay, that's the idea. So I can safely say that at most three zeros will be there. Okay, in fact I can guaranteely say that at least one zero will be there. I'm not saying this with the experience of the 9th and 10th standard. I am actually using a higher level mathematics here. So if you don't understand how this at least one zero must be there, that's okay. You can now believe me, you can put the blame on me saying that Dr. David has said that any cubic polynomial will have at least one zero in my hand. So I can find that zero. Okay, fine. Now similarly, biquadratic polynomial, which is the polynomial of degree 4, right? So biquadratic polynomial. Now biquadratic polynomial will have again at the most 4 zeros. Now here I can't say at least one zero will be there, two zeros will be there here as well. Okay, fine. Now what I'm trying to actually generalize this here is, you take any polynomial, it's actually, you can consider that as a result and keep it for you. It might help you in your JEE or any other entrance examination that we go. Okay, fine. So any polynomial, I'm going to actually give you this result. Any polynomial of even degree has no guarantee that it will have a zero. It will have a zero. But any polynomial of odd degree, if it has odd degree, if the polynomial of degree 3 or if the polynomial of degree 1, you see that I have said exactly 1 here, right? If the polynomial of degree 3 or 1 or 5, I can have one confirmation that it will have, any polynomial of odd degree must have at least one zero. Okay, that's the idea. In fact, I would also write this as a real number 0. In other words, the real 0. You can consider that as I'm talking about a real number which is also a 0 of the polynomial. Alright? Okay. So there's a lot of things to actually take in this particular lecture, and I will see you in the next lecture. Feel free to pause the video, feel free to go back and watch back one more time and whatever I'm saying it. If you do not understand some of the things that whatever I have said over here about at most, at least all of them, do not worry about it. Just forget it. Just take it for granted, or at least leave it. Now what we will do is, in the future lessons, we will be computing the zeros of the polynomials, finding out how many number of zeros of the polynomials are there and what are the zeros of the polynomials are there, and that experience will actually make you understand what I've said here. So don't worry if you don't understand this lesson. Let's get started with the next lesson in the next video. Thank you so much for watching, and I will see you in the next video.